Hi, my name is Damien Pearse. I'm a professor in the Miami project to Cure Paralysis in the Department of Neurological Surgery. My laboratory's interests are looking at preclinical development of cellular and gene therapies for spinal cord injury repair. So recently we obtained a Translational Research Award from the Department of Defense. The goal of that award is to develop preclinically a combination approach using autologous swan cells with a biomaterial. And this biomaterial is generated by a collaboration with a Harvard-based company called Gel4Med Inc. And they have developed a peptide gel which can be functionalized, and that means to be able to provide that gel with extra abilities so that it may be more supportive for regeneration. So in this award, what we're looking at is functionalizing the gel to have the ability to protect the cells during transplantation, as well as provide the transplant with scar avoidance activity. And what that means is that the swan cells, when transplanted, will be able to better support axon growth into the transplant and beyond. And so our goal in this award is to generate the preclinical data that's needed for submission of an investigational new drug application to the FDA to hopefully move towards phase 2 clinical trials with a combinatory approach using autologous swan cells and this biomaterial. So it's very important that we identify new therapies that can improve or restore function after spinal cord injury. The majority of individuals with spinal cord injury have been living with this disability for many years. And so in trying to find ways to improve that function that has been lost, we need to think of approaches that can restore axon growth and get those axons to reconnect and improve function. And so my work has been focused largely on those sort of therapies that can regenerate and restore function after spinal cord injury. We've had very positive results on the safety and feasibility of transplanting swan cells in phase 1 clinical trials. So our hope is to be able to develop more robust approaches based on cell transplantation that can further improve function and restore connection across the injured spinal cord. So when I was young, I was very interested in nature. I was raised in the country, so I would often go out into the bush. I lived sort of near the outback of Australia, and so I interacted a lot with flora and fauna of all different unusual types, and so that sort of sparked my interest in science. There were other opportunities that I considered when I was young, maybe being a lawyer or an Air Force pilot, but those didn't eventuate. So eventually I went to university in Australia. I got a degree in biotechnology, so basically being a gene jockey, working a lot with bacteria and trying to understand how these bacteria could be used in industrial processes. During my travels, though, I attended a conference where I met Professor Mary Bunge, a really esteemed researcher, and I heard all about regeneration and the amazing work she was doing in developing cell therapies for spinal cord injury. And I was fortunate enough that she considered me for a postdoctoral position, and I had a very successful postdoctoral position here under her guidance at the Miami project, and being fascinated with the work and trying to develop new therapies for spinal cord injury, that I decided to stay and have my own lab here. And it's been quite a journey being able to take benchtop research towards clinical trials, and I hope that we can be successful in finding these treatments and helping people with spinal cord injury to improve their lives.